Welcome Honors Algebra 2. We are starting a new section. This is going to be 3-1 functions. So today in this video, we're just going to do half of 3-1, and then we're going to get to the other half of 3-1 in a second video. So we're going to start with what a function is and some of that key vocabulary. So a function, before we can talk about what a function is, we have to talk about what a relation is. So a relation is a correlation between two sets. Typically, we're talking in this class about a correlation between two ordered pairs. So an example of a relation, you would write it in set notation. So that means you're using what we call braces. And it would be like 2, 4, 8, 6, 3, 7, and 2, -1. So this is an example of a relation. It's just a comparison. My x value is 2, my y value is 4. Now it doesn't always have to be like ordered pairs. It can be like people to birthdays. So you can have a mapping diagram. So we call this a mapping diagram. And you have your input values here, and you have your output values on the right side. So let's say I said John, his birthday was November 26th. And then we said, let's say Ryan's birthday is October 3rd. And then Mary's birthday, let's say, is February 2nd. And then let's say, oddly enough, Jan's birthday is October 3rd also. So the way that we show that relation with a mapping diagram, so we draw arrows. So John's birthday is November 26th. Ryan's birthday was October 3rd. Mary's was February 2nd. And then Jan's is October 3rd. So that's a different way. We could do the same thing here. I could have put 2, 8, 3, and we don't typically write the same number twice. So just like 2, 3, 8, and then 4, 6, 7, and -1 on the output side, and draw arrows connecting which ones match. So that is what a relation is. So then from there, we go into a function. So a function is a type of relation in which every x value has exactly one set of y values associated with it. And so what that means is basically you can't have a repeating x value, because what it's saying, every x value has only one y value that goes with it. So it's saying no repeating x values. So a function is a special type of relation. It's a relation, like I said, where it has no repeating x values. So if we look at our two examples up above, I can decide, is this a function and is this a function? So first thing, is the first one with my ordered pairs a function? So I'm looking, and really all I'm looking at are my x's. Is there a repeating x here? And there is. There's a repeating 2. So what that tells me is, because there's a repeating x with different y values, this one has a 4 and this one has a -1, this is not a function. Now this one, okay, John has a specific birthday, Ryan has a specific birthday, Mary has a specific birthday, and Jan has a specific birthday. This one is a function. Now, what would make this one not a function is if John had his birthday November 26th and he had his birthday May 5th, which wouldn't make sense. So a birthday is always like a really good indicator of, or like a real life example of a function. You can have two people can have the same birthdays, but one person can't have two different birthdays. So this one is a function. Now, most of the time, we're not dealing with people and birthdays in this class. We're just dealing with numbers. So really, you're just recognizing the ordered pairs. If there's a repeating x, then it's not a function. If there's no repeating x's, it is a function. Now, most of the time, though, we are looking at graphs. So for a graph to be a function, and you might recall this from Algebra 1, it must pass the vertical line test. This means if a vertical line, which a vertical line, remember, is up and down like this, passes through the graph only once, it is a function. So if I had a line, let's say, I was looking for a piece of paper. Let's use a Post-it. So if I had a line like this, that would be a function because nowhere on the graph is it going to cross a vertical line more than once. If I have a parabola, that's a function because nowhere on this graph is it going to cross this vertical line more than once. Let's say I had a circle. Is that a function? No. Because when I put my vertical line down, it's going to cross through that graph more than once. So it doesn't pass the vertical line test. If it doesn't pass the vertical line test, then it's not a function. Okay, so then domain. What is domain? Remember, domain is all the x values, or sometimes we talk about it as the independent variable, or oftentimes we call it the input. And then the range is all the y values, or that one is the output or the dependent variable. So the domain is all of the x values that can work for that function. The range is all of the y values that can work for that function. So if I were to go back up to this one, even though it was not a function, I can still tell you what the domain is. The domain of this one is looking at just the x values, 2, 8, 3, and 2. Now, we would want to write that in numerical order. And like I said before, we don't write it with repeating numbers. So it'd be 2, 3, and 8. And we do write it in braces when they're just separate numbers like that. And then the range would be looking at the y values. So again, we'd write it from least to greatest. So -1, 4, 6, and 7. Now we could do the same thing here. The domain would be John, Ryan, Mary, and Jan. And then the range would be November 6th, October 3rd, and February 2nd. Okay, so those are kind of like your keywords. Let's start talking about function notation. Function notation is something you might have seen in Algebra 1, but we're going to go over it. So often you see equations written like this: y equals 3x plus 5. What function notation is just essentially saying instead of writing y, we write it as f of x equals 3x plus 5. So let's talk about those parts. So first, this is what function notation is just essentially instead of using y, using f of x. So this is function notation. And then as we recognize, the f of x and the y are essentially the same thing. And then, like I'm saying, I want to be clear that this is said as f of x. So when you see it written like this, you're saying f of x equals 3x plus 5. A lot of information in here. Okay, so then the 3x plus 5, that's the actual function. There's my color, okay. So the 3x plus 5, that's the function. And what we're going to be focusing on the most, really, is the x. And so whenever I see this x, or if you notice down here, whatever is inside those parentheses, that tells me whatever, like the value that I'm going to be plugging in for x. So whatever is in the parentheses is the value you plug in for x. Okay, so let's look at number 1. It says evaluate the function f of x equals x squared plus 2x for the given values. So in this one, it's saying find f of 2, which means, okay, 2 is in the parentheses, so that tells me I'm going to be plugging in 2 wherever there's an x, which there's an x in this equation here, and there's an x there. So that would be 2 squared plus 2 times 2. So we know, okay, 2 squared is 4. And 2 times 2 is also 4. So my answer is 8. Now, you can just write it as 8. Or you can say f of 2 is equal to 8. And what this means, and like what this is saying in terms of this function, is when graphed, a point on this, and this is a parabola because of that x squared, it's a quadratic, and quadratics are always parabolas. So when graphed, a point on this parabola would be 2 as my input and 8 as my output. So 2, 8. So when graphed, a point on this parabola (2, 8). So 2 is the x value. That's the input. That's the value we're plugging in. And 8 is my y value. That's the output, whatever is coming out. Okay, now numbers, pretty straightforward. It gets a little trickier when there's actually just different letters or different variables that we're plugging in. So what's inside the parentheses is a negative x. So that means wherever there's an x, instead of writing x, we're going to write negative x. So that's going to be negative x squared plus 2. And instead of x, we're writing negative x. Okay, so let's simplify that. So negative x squared, that's saying negative x times negative x. Well, the negative and the negative make a positive, and this actually becomes a normal x squared. And then 2 times negative x, well, 2 times that negative 1 becomes negative 2, and then the x is there, so it's minus 2x. Is there anything further that I can simplify? I can't. There's no like terms. So f of negative x is equal to x squared minus 2x. And that's it. So whenever you guys have, so with a number, your answer should be a number. But when you're plugging in a new variable, your answer should technically be a new function, something with a variable in it also. So if we look at C, we're plugging in x plus 1. So what I want you guys to do is just try right now, plug in x plus 1 into our function up above that we've been plugging in for, and just come back and see if you plugged it in right. You don't have to multiply it out, just plug it in and see if you get it correct. Okay, so hopefully you've tried on your own. So that's going x plus 1, that's in place of x, squared, plus 2, and then in place of x, we're putting x plus 1. So notice everything, instead of writing x, we're writing whatever's in the parentheses, x plus 1. And instead of writing x, we're writing whatever's in the parentheses, which is x plus 1 again. So as we know, x plus 1 squared is not just distributing. Remember, you have to expand and multiply here. Super, super important. So that's saying x plus 1 times x plus 1. And so we can multiply that out. X times 1 times, or x times x is x squared, plus 1 is 1x, plus another one is 2x, plus 1. And then we just distribute this too. 2 times x, 2 times 1 is 2x plus 2. Now, is there anything I can simplify here? And there is. Unlike with this one, there weren't any like terms. There are like terms here. I can combine 2x, and I can combine 1 and 2. And I get my new function to be x squared plus 4x plus 3. And so that's it. F of x plus 1 is equal to x squared plus 4x plus 3. And that is my final answer. Okay, so D is asking me to find f of x plus h. So what are we plugging in for x? Whatever's in these parentheses. So we're plugging in x plus h. So start there. Start by plugging in x plus h, again, wherever you see an x. Okay, so you should have plugged in x plus h. So that's going x plus h squared plus 2 times x plus h. Now, just like we had to expand and multiply for x plus 1, we have to expand and multiply for x plus h. It's x plus h times x plus h. So let's multiply that out. X times x is x squared. X times h is just xh. Nothing we can do there. H times x is xh. And h times h is h squared. And then I can still distribute this one, 2 times x and 2 times h, which is 2x and 2h. C, is there anything that I can combine? And the only things I can combine are xh and xh. So I'd write that as x squared plus 2xh, because there's 2 of them, plus h squared plus 2x plus 2h. And so that would be my final answer. So f of x plus h equals this whole thing. There's nothing more I can simplify there. So that's all I can do. That would be it. Okay, so let's move on. This part D is actually gearing us up for the next thing. So the difference quotient is something that we expose you to, but it's not really something that you fully apply until calculus year. So calculus is where you really apply it and figure out how it's applicable. But right now it's just kind of like an exposure to it. So when we're going through this process, it says find the difference quotient of f of x equals x squared plus 2x, which is the function we were using before. That is find f of x plus h minus f of x over h for the given function. So we're just going to take this step by step by step. So I'm going to write some steps over here. my first step is going to just be to find this part. Find f of x plus h. Okay, so f of x plus h. Now, let me actually rewrite this a little bit bigger. So I'm just rewriting the difference quotient. And the difference quotient doesn't change, but I'll always give it to you. So it's not something that you have to have memorized, but it is something. So f of x plus h. Now, we already found that on the notes from before. We already found f of x plus h for this x squared plus 2x. So I'm not going to redo that. I'm just going to use that work again. So f of x plus h, I'm just going to copy that, was x squared plus 2xh plus h squared plus 2x plus 2h. Okay, so that's step one. Now, if you're wondering, again, where we found that on the prior page. That was example 1D. Okay, so that was this portion. Then we're going to be subtracting f of x. Now we have f of x. It gave us f of x. F of x, we know this portion is x squared plus 2x, which, so we don't have to do anything. That's not like another step. It's given. It will always be given to you. So our second step is to plug f of x plus h and f of x, because those are two different things, into the difference quotient. Because this is really just like a formula. So in for f of x plus h, I'm going to write it over here so I have room. We're going to plug in that whole thing. So x squared plus 2xh plus h squared plus 2x plus 2h. I'm going to run out of room. Minus, and then we plug in f of x. So f of x is this whole thing. We do need to put it in parentheses because we are going to be distributing that negative, divided by h. That's never going to change. So what does change is whatever f of x plus h is and whatever f of x is. But then the h always stays constant. So then from there, step 3, once we plugged it in, because we plugged in f of x plus h and we plugged in f of x into the difference quotient, which is this. My third step is to just simplify as much as possible. So with that, we're going to distribute this negative, negative, and negative. And I know I'm just going to rewrite a lot, but I want you guys to see this. So x squared plus 2xh plus h squared plus 2x plus 2h. And then that minus gets distributed. So it's minus x squared minus 2x. And so what happens is x squared minus x squared can cancel. And then 2x minus 2x also can cancel. So I'm left with 2xh plus h squared plus 2h over h. Okay, well, what do all of those terms and the numerator have in common? 2xh plus h squared plus 2h. They all have an h. So we can factor out a GCF of h. And I'm left with 2x plus h plus 2 divided by h. Well, and what happens? Well, the h and the h simplify to be 1. So my final answer, sorry I'm moving it all over, is 2x plus h plus 2. And so this whole thing simplified to be this. And these are always like, these do have a pattern to them. They always are going to pretty much simplify to be something much simpler than the whole process. So you'll always be canceling out. You'll always have a GCF of H. You'll always be able to cancel out the H. There's a pattern to these that's so like routine that you'll start to get the hang of it. Okay, so let's look at number 2. It says, again, find the difference quotient of f of x equals 3x plus 1. That is fine. Same thing. Same difference quotient. That's never going to change. So first thing we're going to do is find f of x plus h. So what I want you guys to do is find f of x plus h for our function 3x plus 1. So I want you guys to pause me here and try that on your own. So just pause and try that on your own. Okay, so f of x plus h, remember that's just plugging in x plus h wherever there's an x. So 3, and instead of x, we're plugging in x plus h plus 1. We do have to distribute, so we have to distribute that 3. So that would be f of x plus h equals 3x plus 3h plus 1. Now, there's nothing we can simplify there, so we just leave it as is. So I found f of x plus h. I have f of x, and now I can plug those in. Step 2, plug f of x plus h and f of x into the difference quotient. So f of x plus h is going to go here. F of x, which we know is 3x plus 1, is going to go there. So we're going to plug that in first. 3x plus 3h plus 1 minus f of x, which is 3x plus 1, all divided by h. So as we go through, we need to distribute. So that's 3x plus 3h plus 1 minus 3x minus 1 all over h. We can cancel anything that we can. 3x minus 3x cancels. 1 minus 1 cancels. And I'm left with 3h over h. Now, what happens with h over h? H over h is 1, and my final answer is 3. And so that does it for our difference quotient. We'll do more examples with these, but you can come in and ask me more questions in class. But let's move on to operations on functions. Okay, so our last section that we're going to do today is operations on functions. So it's essentially just taking two functions. We're going to be adding, subtracting, multiplying, dividing. It says state the domain of each. We're not going to do that. So we're just going to cross that part out. We're going to talk about domain in the next video. Get excited. Okay. I don't know why I didn't box this, but that would bother me if I didn't. Okay, so it's asking us basically to add. So looking for my color. It's basically saying take f of x and add it to g of x. So f of x is 2x squared plus 3. And then we're going to be adding 4x squared plus 1. And so all we have to do is combine like terms. 2x squared can combine with 4x squared to get me 6x squared. And then 3 can combine with 1 to get me 4. And that's all it is. So with f minus g, the only thing that changes here is it's f, so 2x squared plus 3. But because it's subtracting, hopefully you know what I'm about to say, with g, we are going to have to distribute that negative. So what I want you guys to do is go ahead and pause me and finish this problem. Distribute the negative, combine like terms, and then go from there. So make sure you guys try this on your own and come back and check your work. So you should have distributed the negative. So that would have been 2x squared plus 3 minus 4x squared minus 1. So then we just combine our like terms just like we did before. 2x squared minus 4x squared is negative 2x squared. 3 minus 1 is 2. And that's it. That's as simplified as we can go. Okay, so from there, part C is asking us to multiply. So it's saying multiply 2x squared plus 3 by 4x squared plus 1. So what I want you guys to do, you're distributing, you're multiplying that out just like you would in Algebra 1. It's just multiplying. So I want you guys to pause me here. Try this one on your own. So I can't remember if I told you to pause me here and multiply it out, but I'm thinking I did. So pause me here and multiply it out. I'm going to multiply it out too. So I multiplied mine out, and now I'm going to combine my like terms, and I got my final answer to be 8x to the 4th plus 14x squared plus 3. And again, like if you guys have any questions and want me to go over any of these in class, I'm happy to do that with you guys. Okay, now last operation is dividing. So it's saying f, which is 2x squared plus 3 divided by 4x squared plus 1. Can I factor the top? 2x squared plus 3. No. Can I factor the bottom? 4x squared plus 1. No. That's all I can do. That is my answer. Oh, that's exciting. Okay. So that was kind of a basic, like f is a polynomial, g is a polynomial. Let's do it with rational functions. So f plus g, that's just doing x minus 4. And I made these a little bit easier. Plus, because we're adding 3x over 2x plus 5. Now, why am I saying I made these easier? Because they already have a common denominator. So we don't have to worry about getting a common denominator because they already have a common denominator. So we can just combine like terms in the numerator. X plus 3x is 4x. Minus 4 can't combine with anything. And 2x plus 5. Now we could factor out the 4 and have 4 times x minus 1, but that wouldn't simplify anything, so we can just leave it as is. If you did factor out the 4, that would be fine too. So it's up to you, whatever you want to do. Okay, so what I want you guys to do is try the f minus g here. It's the same level of difficulty as A. You're just subtracting. So I want you guys to set that up, try it out on your own, and then come back and check your work. So I set mine up, and now I'm going to, because they already have a common denominator, I can just combine like terms. This is the same as this one. I could factor out a negative 2 and have negative 2 times x minus 2, but it wouldn't cancel anything. So you can leave your answer just like this as well. And that's it. Okay, so let's move on to multiplying. So we're multiplying. We have x minus 4, f of, so f is x minus 4 over 2x plus 5 times 3x over 2x plus 5. Can anything cancel? No. 2x plus 5 and 2x plus 5 are both in the bottom, so they can't cancel. 3x can't cancel with anything. X minus 4 can't cancel anything. So the way that we write this is just 3x times x minus 4 over 2x plus 5 squared. Please do not multiply it out. It's unnecessary work for you guys. I don't need you guys to like multiply it out. You're just showing that you understand what these operations mean. Last one. So we have f x minus 4 over 2x plus 5 divided by 3x over 2x plus 5. Now, if I gave you a problem like this in our last sections, what would I tell you to do? I would tell you to expand and rewrite it. So it'd be x minus 4 over 2x plus 5 divided by 3x over 2x plus 5. And now we can multiply the reciprocal. So I'm going to put it below. X minus 4 over 2x plus 5 times 2x plus 5 over 3x. Now what can I do here? Do I have anything I can cancel? Yes, I do. 2x plus 5 and 2x plus 5 can cancel. And I'm left with x minus 4 over 3x. Nothing else can simplify there. So that is my final answer. And that is it for part 1 of the 3.1 notes. So if you guys have any questions, bring them to class. We can go over them. Make sure we're going to do a lot of practice with the difference quotient, so don't worry about that one. But if you guys have any questions, ask them in class. I hope you guys have a great day, and I will see you soon. Bye, guys.